Here at Graham School, a specialist science and arts college in Scarborough, a class of Year 9 students is focusing on how mathematics is used in different careers. Throughout the day, they'll be taking part in a number of activities intended to show how the skills they use in the classroom relate to jobs in the real world.
Morning. How many of you in here have got paper round? Put your hand up for me, please, if you've got paper round.
To start off the lesson, teacher Daniel Gadd is asking some of the students to deliver newspapers to their classmates.
I've got some newspapers here and I've put 4 people's names on them. Matthew, will you deliver them for me, please?
The students who are due to receive the papers are on opposite sides of the room, meaning Matthew will have to retrace his steps. However, the second student has a different approach to the task.
Thank you very much. Sit yourself down. Tell me why you did that.
Instead of going forward and back, you just do you just do like that table and then that table.
And what does that do? Why did you do that?
Time.
Saves time. Okay, excellent. I gave the papers out because I wanted to see how they think to start with. It's one of the things. If I give them the papers, some people will sit there and work out their route before they're going to do it. Some will just say, okay, got to give that to John, go and give that one to Andy, and do them in the order I gave them out. It's relevant. Some of the students in the class have paper rounds and actually have that thing to do in the morning or in the evening after school is to look at their round, where they're going to deliver papers to, and make a decision on which order I'm going to do them in.
Expanding on the exercise, Daniel gives the class a task on a larger scale.
The problem I'm going to give you to start with, all right, is can you go down every single street, but only down each street once? You don't want to waste time on a paper round by going back down the same street a second time.
I think we need to start around here, because that way you've got...
They're going to start from the top and go down to the bottom.
The activity introduces the students to network diagrams and how mathematics can be used to aid efficiency.
Oh man, I nearly did it. I just missed 2 lines.
They attacked the activity exactly how I thought they would, just by trial and error. Yeah, starting somewhere and trying to do it, and then start, if I can't do it that way, start somewhere else. And once they've found one, it actually gets around the room fairly quickly that if you start there, you can do it.
The students have come up with a number of different solutions to the problem, but they all have something in common.
Excellent. What do you notice about what we've just done?
They all start and finish in the same place.
Okay. We started and finished on these 2 points. Now tell me what's happening there. Andy?
There's 3 different directions that you can take.
Okay. And we finished down here. What's special about that junction?
There's 3 different directions that you can take.
Okay. Now, did anyone find any other way of doing that route? That's because it's not possible. Okay? You must start and finish at one of those 2 points. There's 2 nodes or junctions where there are 3 streets coming into that diagram. You must start at one and finish at the other, because otherwise you can't visit all the streets. If you start at a junction on that diagram with an even number of nodes, the solution's not possible.
This is a real-world problem which mathematics can be used to solve.
So if I've got a diagram, all right, a network diagram of a route, I can tell just by looking at it where I need to start, where I need to finish. If it's possible to do that route without going down the same road twice, that might be important to supermarkets, haulage companies, people delivering things to people to save on petrol, to save time and to maximise, to make the most profit. Yet some haulage companies employ people called logistics managers to design their routes so that they are saving petrol, saving diesel, saving time. The aim was to try and provide some real-life examples of problems that appear in the real world that involve maths, to try and spark some life into maths, if you like, give them some idea of the sort of problems that are out there, the sort of careers that perhaps they hadn't even thought of existed, and the maths involved in those.
Using motivational teaching and learning techniques like this one is a way to show students the subject in a more positive way and may encourage more of them to choose mathematical careers. The next problem is a cabling exercise, in which the students have to plan how they can connect a number of towns with cable TV, using the minimum amount of cable. This differs from the previous exercise, as they don't need to join the points in a continuous loop.
Take that one out and put that one there. So then if I've used one.
Yeah, but then that ain't connected to that.
You ain't connected to them too, innit?
I'm going to put a cable along that road. I'm going to put a cable along that road. I'm going to put a cable along that road and that road. Up that road, up that road. They're all connected together now.
Could you take that one out?
Okay, so I could take that one out and put that one in, right? Okay. I'll put that one in then, so take that one out. Okay. Now, what is the shortest amount of cable that I can use? Are you with me? So I've just done that haphazard to show you what we've got to do. Is there a way you can work out how to connect them all together, but use as little cable as possible?
While some students can easily work out the problem on paper,
You can be clear thoughts.
for some it helps to use props, such as ropes, to figure out their solution. This gives them a concrete experience as opposed to an abstract one. Here the students are modelling the cable laying exercise by using posters displaying the different town names and a long piece of rope to represent the cable.
Okay, here has Westgate. Okay, you have the end. And then 1 metre away we need Grimsby. Okay, you hold that. And then you two come up here. And then that joins on to Westgate. And then if from Grimsby we need Wheelsby Road, which is 4 metres away. And then it would be New Waltham here, and then it would go off to the golf club.
Does it need to go back to the golf club?
No, because it's already connected.
Because everything's already connected, isn't it?
And then we've got them all together.
Brilliant. The reason they're valuable exercises is that they're real-life problems. They're real-life things that someone out there has to do, and that it shows them that the relevance of maths. It also gives them something to think about, so we're using thinking skills and communication and group work skills, which is again something else that when they leave school, the sorts of skills they're going to need to be able to use to work effectively.
As communication is an important part of work, the students practice this by presenting the results of the cabling exercise to the rest of their class.
We tried to get rid of most of the bigger roads. Like we did the 7 kilometre one, we got rid of that and changed it with the 4 kilometre one to use less petrol and less different distance.
Can you tell me then why it's important that you would use the shortest length of cable to connect all these towns together?
So you're not wasting cable because it costs money.
How are you saving money?
By cutting how much cable you use, so you don't have to buy as much. By not hiring as many men, so you get the work done quicker, because you haven't got as long a distance to go.
The aim of these exercises is to introduce the students to ways in which mathematics is used in different professions. This is taken further in the final activity. For the last part of today's lesson, they're watching videos from the internet of real people in real jobs. They will use the information they find to present how these people use mathematics in their daily work. The sports engineer is one role that you would expect to use mathematics.
Okay, this is the BATAC Pro machine. This is used for athletes to train reaction times and develop the speed, particularly used by Formula 1 athletes because it's good for the periphery vision, for looking to the corners of where you can see, and also speeding up your reaction times in corners and things like this. There's 2 scores that we can get from this piece of equipment. If we divide the number of hits by the time taken, then we get the average rate, so the number of buttons you hit per second. But we can also calculate how long it takes to hit each button, which is reaction time. And to do this, we take the time and divide that by the number of hits.
But a costume designer is one area that you wouldn't necessarily associate with mathematics.
A lot of the costumes I do are prop costume, and they involve problem solving. And one of the problems I had with this was I was making some costumes for a TV programme, and they needed a giant pair of boxing gloves. The idea being that he had to walk in dragging his knuckles on the floor. And so what I did was measure how tall the actor was and worked out roughly how far from his arm to the ground, and then that worked out at 5 times the length of this. So what I realised was I would have to scale up by 5.
If I said to a student, what does a costume designer do? They would turn around and say design costumes, and if I said to them how much maths is there involved in that, they would say none. But actually, if they think about it, there's a little bit more than they'd initially thought.
I think it's important in costume design because you need to know how much material you need and like how many metres and like if you need pins to like pin it up and like sewing machines.
The students will also be using the internet to find out about other jobs that use mathematics, presenting the results to their fellow classmates.
To calculate the reaction time, an engineer must divide the time taken by the number of hits. A Formula 1 racer would need to know their reaction time because they need to go around corners at high speeds.
Here are some examples of calculations carried out in the sports engineering job. Finding an average of how many hits a tennis racket can take. The reaction time of a tennis player. Finding how well a tennis ball will travel through air. And the person has to find techniques to help them carry out investigations.
So, based on their research, what jobs involve mathematics?
A bricklayer, because you need to know how many metres you're going to lay the bricks in the area where you're going to lay the bricks.
A vet, because you need to know the measurements of the medicine that they're going to need.
Plumber, because they have to measure all the walls and the pipes and all the stuff that you have to put along.
Air traffic control person, because the person who's driving the plane needs to know how far they need to go to land the plane.
A decorator, because you need to know how much paint or wallpaper you need.
Chancellor of the Exchequer.
Why Chancellor of the Exchequer, John?
Because he's the only one who can actually save Britain from the recession.
I think they've learnt that there are more careers out there than they'd perhaps considered in the past. That there's more maths involved in some of the things than perhaps they'd considered in the past.
Without maths you can't really do a lot of stuff, and if you do it like this it's quite enjoyable.
I enjoyed it more because it's more maths that we're going to be doing in the real world for jobs and work.
For that class in particular, that class is a Year 9 class just deciding on their options, so looking at different careers and careers perhaps that they hadn't even contemplated is a good idea, and actually seeing the relevance of a core subject in those careers is very relevant to them.